Welcome to The Explainer, where we break down big ideas. So today we are going to dive into a really fascinating question, and we're going to use a new theoretical framework as our guide. Okay, so let's get right into it. What does a scientific revolution actually look like? It's really not about a single eureka moment where everybody just suddenly changes their mind. No. The sources we're looking at today suggest it's this strategic, deeply human, and, often political process. It's full of resistance, ego, and just immense opportunity. So to really understand this, our case study is going to start with a pretty radical new idea. It's called the harmonic scale framework, or HSF for short. And believe me, it proposes a fundamentally different way of looking at pretty much all of reality. So what is HSF? Well, in a nutshell, it proposes that everything we see, and I mean everything, from gravity and mass to the forces that hold atoms together, it all comes from one simple underlying wave mechanism, plus a little bit of geometry. It's an incredibly bold attempt to unify all of physics under one single elegant umbrella. Now this is where it gets really interesting. Just look at the contrast. On one side, you've got our current model of physics. It's a patchwork of 6 brilliant but totally separate theories. And on the other side, you see the core appeal of HSF. It collapses all of that complexity into one single coherent mechanism. And for scientists, that's kind of the holy grail, finding one simple rule that explains everything. Okay, but let's be realistic. How would a radical idea like this even get a hearing? It just doesn't happen overnight. Any new theory has to survive this incredibly rigorous, extremely conservative process, a process that's literally designed to weed out everything but the absolute best ideas. And this, right here, this is the gauntlet any new theory has to run. First, the math has to be perfect, totally airtight. Then, and this is huge, you have to prove your theory doesn't break everything we already know works. It has to include the giants like Newton and Einstein as special cases. But the real test? Predicting something brand new, something nobody has seen before. And finally, other people, totally independent of you, have to be able to prove it for themselves. And if you think this happens quickly, think again. This is not a fast process. Our sources suggest that even for a correct theory, the path from just an idea to an established framework can take up to 20 years. History shows this pattern again and again. For every big idea, from relativity to quantum mechanics, it just requires an incredible amount of patience. But this whole process isn't just about math and data. As we're about to see, there's a powerful and often overlooked human element at play here, and that is ego. See, the sources we're looking at suggest that science isn't always this pure, noble search for truth. It can also be a social structure, a prestige hierarchy, where your identity, your career, your entire status is tied to the current consensus. Being in or out of that circle really matters, and that creates this powerful, built-in resistance to any new idea that threatens the established order. So, this is the really crucial point. How does change actually happen in a system like that? It's not about scientists standing up and admitting they were wrong. I mean, that would be a direct attack on their own identity. Instead, it's a strategic reframing. The new idea gets presented as an upgrade, a deeper model that actually includes the old theories. This brilliant little move allows the old guard to save face and lets the revolution move forward. So, okay, if the Western scientific establishment is culturally and institutionally resistant, where would a revolution like this actually begin? I mean, who's going to take that first big leap? And this is where our little thought experiment takes a really surprising geopolitical turn. The prediction isn't that the revolution will start at, MIT or Cambridge. Nope. It's that it will start in places where the core ideas of something like HSF aren't so culturally foreign to begin with. The sources predict that nations like India and Japan, whose ancient philosophical traditions, like Vedic cosmology or Zen, already see reality as being made of waves and vibrations, they'll be the first to seriously test a theory like this. Meanwhile, the West's ideological resistance and its rigid academic structures, well, they might just create a critical delay. So this raises a final, and honestly a really powerful what if. What happens if a theory like HSF is correct, and the West, which has led science for centuries, is the last to accept it? The argument here is that a fundamental shift in physics is never just an academic exercise. It has, throughout history, unlocked entirely new fields of technology. And in doing so, it has shifted global power.
I mean, just think about the atomic age or the information age we're in now.
I mean, look at this list. We're talking about technologies that sound like they're straight out of science fiction today, but they could redefine everything: energy, medicine, communication, space travel. The nation that gets there first wouldn't just get an economic edge, it would gain an immense strategic advantage for the next 100 years.
And that leaves us with a pretty provocative final thought. This whole explainer really shows that the journey of a big idea, it's about so much more than just science. It's a story of human psychology, of institutional inertia, and even geopolitical strategy. The battle for the next scientific revolution might already be underway, and it's being fought not just in labs, but in the minds of scientists and maybe in the very cultures they belong to.